Good afternoon, everyone. I want to start off with a quick raise of hands as much as I can see it, but like, how many of you have actually built an agent before? All right, that's a few. How many of you feel like, even though you've heard the word agent a million times today, like you have a good grasp of what an agent actually is? All right, that's not a lot of hands. So hopefully in the next 45 minutes, we can clear some of that up. But first of all, my name is Dominik Kundel. I work on developer experience at OpenAI. And no, even though my name might hint at it, I am not Polish, so I'm sorry I will not be able to talk to you in Polish. And I'm losing my microphone, there we go. All right, so let's start actually talking about what an agent is so that we can all get on the same page. A lot of things call themselves an agent today, and it feels like everyone sort of has their own definition. So when I'm talking about an agent for the next 45 minutes, I want to make sure we all have the same definition. So when we talk about agents at OpenAI, we talk about systems that can solve independently tasks on behalf of a user. That means they're normally set up by having a model, a set of instructions, the tools to actually resolve that task, and then they are normally wrapped into some version of a runtime or what we call a harness. And that harness then facilitates the execution of the agent and returns the output back to the user. I want to give you some concrete examples of what an agent might actually look like by giving you three examples from the OpenAI ecosystem. The first one is Codex. How many of you have heard of Codex or even used Codex? All right, that's way more people than earlier with the agent definition. So Codex, for those of you who don't know, is our software engineering agent that is meant to be part of your development team and act almost like a senior software engineer on your team, solving problems. And to do that, the Codex agent has tools to navigate your file system, perform actions using shell commands, view images, patch files, and all of that can then lead to the agent being able to implement features, test, debug code. In practice, the way this looks like, to give you an idea, is this is Codex in the CLI. It can also work in a variety of other interfaces, but we can say how many examples are written in Next.js. And in this case, we're going to have the agent actually navigate this repo, which is our agent.js repo. It's using some tools like ripgrab and others to navigate the file system using bash, and then hopefully gives us a response here that there's two different repos. All right. The other example is actually directly within ChatGPT. If you go beyond sort of the basic question and answer world, and you can actually get ChatGPT to do real work for you, because it can access things like data sources from browsing the web to accessing things like Google Drive. It has tools to create reports, draft slides, create Excel sheets. It can even use Python to analyze data and perform actions. So I actually did this beforehand, just so you didn't have to wait. But I asked ChatGPT to create me a clean and pretty Excel spreadsheet of the whole agenda of WAWTech. And it went ahead here and it worked for a bit. But what it did, what you can see here, is it actually did sort of the same thing that you as an engineer would probably do if I asked you to create me a spreadsheet. You're not going to manually fill it out. You're actually going to start writing some code. And so it fetched the HTML from the page here, and then went ahead and wrote a bunch of Python code to process this using beautiful soup. I'm just going to skip through a bunch of this. It debugged its logic because it had to figure out how to parse it. And eventually, it started creating a spreadsheet using that same Python logic. And if we scroll a bit more here, we're going to get to a point where there we go. It then actually took a picture or two pictures here of the spreadsheet to analyze the spreadsheet's setup, because we said it should be beautiful and well-structured. So it analyzed it, checked it, and then ultimately shared the full spreadsheet with me here, so we can see it has all of the sessions in it, and I can go download it and interact with it. The last example that I want to give you is ChatGPT Atlas. So Atlas is our AI-enabled browser that you can either just use as a regular browser, or you can use the agent mode, at which point an agent can actually take over the browser tab and start performing tasks in it. It can move the cursor, it can search for things, it can even inspect the page. And so it helps you to automate common tasks, and we can briefly see this in action here. This is Atlas. So if I go in and I ask to use agent mode, there we go. Is the conference available? Oh. If I could type, that would be better. Conference available online. We're going to see agent mode actually taking over my tab. It's moving around the cursor. After inspecting the page and figuring out where should I go, it decides it should click on FAQ. It's waiting for the page to load. It sees a question there, and it's clicking on it, unfolding it, and actually able to access it. So we're not going to wait for this to fully respond. And instead, let's go back to the slides here. Okay, so we covered 3 concrete examples of what an agent is, but how do you actually build your own? We're going to go through the whole journey from idea to scaling, and hopefully there is a lot of tips along the way that you can take in mind, but fair warning, this is going to be information dense. All right, so when I talked about an agent definition, we talked about the agent solving problems on behalf of the user. So the first thing you need is to actually be clear about what are the tasks that you're solving for the user. And so when you're building an agent, my recommendation is to start with one task. Don't try to boil the ocean and pick a million tasks. Pick a single task, because it's easier to focus both for you during the development and for the agent to focus on a single task, and you can measure success with that. You can always iterate on it and then add more tasks later on. So in practice, for example, if you're building an agent for coding, maybe not start and it should do everything that every other coding agent does. Start off with, it should be able to navigate the code base and answer questions based on that. And then later on, you can add things like editing files or running commands. Now that you have a purpose and a task defined, it's time to pick a model. And there's obviously a lot going on. I think there's at least one new model dropping every other day. And so it's hard to pick them, and I would not overthink it. Try to pick a first model and start working on a prototype. Ideally, pick a state-of-the-art model like GPT 5.2, and then later on explore if you can switch to a mini model, but don't try to immediately optimize for that. The other thing that is very interesting these days is that these models are moving beyond just having sort of the same functionality and just text completion to actually having additional capabilities. And this goes beyond multimodality, like text, like image input, to things like being able to know how to use shell tools, computer use, web search, and others. So if you're building an agent that has a task that relies on these capabilities, you might want to pick your model based on those native capabilities as well. And we're going to talk about that a bit more later on. Some of these models, like the GPT-5 series, also have reasoning efforts now. Don't try to crank that to 11 immediately and pick the highest reasoning level. Instead, start somewhere with medium, or if you don't even care about reasoning, you care about latency, just choose none. And then later on, if you see the model struggle, you can crank it up. But if you're choosing things like extra high reasoning from the get-go, you might see the model overthink tasks. With the model set, we now need to pick instructions or do prompt engineering. And unfortunately, just like humans, every model kind of follows instructions slightly differently. So even if you already have a great prompt, switching the model will mean that you will probably have to do some tweaks. So the following tips are specifically for the GPT-5 series, but a lot of them should be applicable to similar models as well with some tweaks. The first one is start simple. Don't have writers block and stare at it for hours trying to figure out what the perfect prompt is. Start with a couple of sentences. Maybe use ChatGPT as a meta prompter. And then later on, you can also use the prompt optimizer in the dashboard to tweak your prompt. One of the things that is interesting about models like GPT-5 is that they're increasingly better at instruction following. What that means in practice, though, is that if you write bad prompts, they might create more trouble. So if you have conflicting information, for example, the model tries to adhere to the information, but you gave it conflicting ones, so it doesn't really know what to do. Similarly, if you give it overly firm language or do things like tell it to always thoroughly check the code base, that might have been fine in previous models, but with models like GPT-5, you might see it actually go down a rabbit hole and really thoroughly check the code base by visiting every file. So be careful with overly strong language. One way that you can actually avoid some of these things is to properly structure your prompt by using either an XML-like syntax or a Markdown-like syntax, because that makes it both easier for you to maintain the prompt, because it's very easy for you to follow and less likely that you introduce issues. It also makes it easier for the model to follow. And if you need some inspiration, the prompts for Codex are actually fully open source. So if we go here, you can find them all on GitHub, and they're broken down by model. So you can actually read through them, and you can see here as I'm scrolling through this is very readable. There isn't a lot of like yelling in all caps. I know you all do it. We're not threatening anyone here or other things that you've tried. There's sometimes emphasis, but it's very easy to follow these prompts. So give that check that out if you need some inspiration. All right, now we have the prompt, we have the model, we need a harness. I talked about tools earlier, but actually choosing the harness first helps you, because sometimes the choice of your harness is going to inform what tools you have available. So let's talk about harnesses first. The first one, if you're using OpenAI models, the first option for you is the Responses API. We released this earlier this year, and it's taking a lot of the learnings we had from APIs like chat completions and built on top of that. And the reason why I'm talking about an API, an inference API in the harness section, is that we actually designed the Responses API to be agentic by design, meaning it has things like hosted tool capabilities that allow you to build a full agent in a single curl request. So if you're looking at this request, this is a full agent that has access to web search. It can use Python code to crunch numbers. It has access to my Google Calendar. It also can perform file search through the vector store that I uploaded and using Agentic RAG, and all of that in a single web request. And even if you're not, if you need some like additional client-side logic, you actually want to use like an agentic framework, make sure that if you're building with the OpenAI models, you're using one that actually uses the Responses API under the hood. Talking about agentic frameworks, I know there is a million, and we could probably talk about all of them, and it's kind of like picking a web framework these days, where everything has a slight different philosophy. People are worried about picking the right one. Honestly, I think it's similar to picking a framework. The biggest choice that you can, the worst choice you can make is not picking something and just start building, because ultimately that's how you're going to learn if something works for you or not. And so if you aren't sure what to pick, check out the OpenAI Agents SDK. It's fully open source. It's available in TypeScript and Python, and it works with non-OpenAI models. It also has some functionality built in like tracing, which we're going to talk about later on. And it's intentionally lightweight so that like it doesn't add any huge overload, and it should be easy to both migrate onto it and off it if you later on change your mind. There are moments, though, where you don't really care about the harness. You don't care about what tools it has or other things. You just care about it getting the job done. A good example of this is maybe you want your agent to be able to code. You don't care about what that harness looks like. It's not your secret sauce. So you can use the Codex SDK, for example, to programmatically control the Codex agent directly on the machine. And so this means that you can benefit from the same work that the Codex team is putting into like the agent that powers the Codex CLI, including the same prompting, sandboxing, tool optimization, and then you can programmatically call it from your own code or even combine it with the agent's SDK if you have another agent that needs to just hand off to a coding agent. Now that we covered the harness, we need to actually add the tools. If we don't add tools to the agent, it's not an agent, it can't actually solve the problem. Most of you are probably familiar with function tools. These are by far the most widely spread. Most recent models now support function calling. At its core, the way it works is we provide a definition of a function or multiple functions to a model with a description of each, and then the model decides if it wants to call one. And then we actually go, as a harness, you have to receive that request, run the actual logic, and then pass the tool output back to the user, or back to the model. This is by far the most versatile solution, but it does add some overhead. It requires you to actually handle the tool calls. It requires you to deal with network overhead, where you have to do multiple turns to the model. Another option that is increasingly popular, though, is Model Context Protocol, or MCP. This is an open standard, which means that you can actually take the tools and move them easily between different harnesses, between different agents, and it's great for that. It's also great if you have a use case where another team might be maintaining all of the tools and you're maintaining the harness, for example. But it does come with its own sort of challenges. One, ultimately the MCP server is in control of the definitions, and so it's a bit harder to control that. And under the hood, it still translates to function calling, so the harness still has to do a lot of the same work around actually executing the tools, passing the results back to the model, and on top of that, now you need to manage the connection to the MCP server. The last category is built-in tools, and we briefly talked about this, but increasingly these models are being trained on specific tools for specific tasks. So whether that's web search, computer use, using a code interpreter or bash, these models are being trained on these tools, and that means that they really know how to solve problems with these tools. So relying on them, or at least being aware of these built-in tools for your model, is incredibly helpful for you to improve the accuracy of your agent. Cursor, for example, actually tweaked their agent harness for the Codex model by being aware that the model tends to use ripgrab to search for files and cat to read files, and adjusted the prompts and definitions of their tools to improve the accuracy of the model of the agent with the Codex model. So overall, I would recommend you to start with built-in tools to get really the best performance out of the model. And while MCP is great, I wouldn't rely on it if you don't really have the use case where another team or a user has to bring their own tools. If you have full control over the agent, I would recommend you to actually just build function tools and have full control over what they call. You can still connect to the same MCP servers behind the scenes, but it gives you more control. It's also worth calling out that regardless of what tool you're using, tool input and output still ultimately are part of the model's generation. And so making sure that you keep an eye on that, how it might impact your context window, but also sandboxing the environment and the tools if they're calling any kind of critical things is important. The other part, if you're designing your own tools, whether it's through MCP or function calling, is to be aware of the natural capabilities and strengths of the model. For example, a lot of the models these days are really good at bash and coding. And so things like Cloudflare's code mode, where it writes TypeScript code to actually execute MCP calls, is a great great example of like Cloudflare leveraging the natural strengths of the model. Lastly, if you are using any of the recent reasoning-based models from OpenAI, do make sure that whatever harness you're using actually uses the responses API, since it materially impacts your performance. All right, we have an agent. Now we need to actually put it in front of people. And before we can do that, we need to talk about the user experience, because there's a lot of ways that we can surface an agent to the user. And it all starts with like adjusting the personality. How do we want the user to actually engage with the agent? How chatty should it be? Should it ask follow-up questions or just storm off and do work? But there's also some fundamental decisions to make, like, is it a chatbot in the first place? A lot of agents still rely on that chatbot interface, including the 3 examples that I showed you all had a chat experience. But there is increasingly more agents that we're seeing run in the background as background agents. These are great, especially for tasks that might take a long time or are inherently event-driven. Like for Codex, we have code review tasks that automatically get kicked off for new pull requests, and those are completely operating in the background based on the context of the pull request. And you can see, you can later on inspect what's happening, and it's pushing back context back into the GitHub UI, but it's operating fully in the background. If you do build a chat, there might be a reason for you to go beyond just text, though. Widgets are a great way to add some rich interaction mechanisms, especially if you have situations like really rich data that might be hard to convey in just text, or you want to have some user interactions that you want to steer more directly, like confirmations, for example. Once you design the user experience and you're ready to ship it to your first testers, you should have observability in place. This seems like a thing that you deal with when you're scaling, but with agents, it's important to have these things in place from the get-go, because it allows you to monitor the behaviors and see what's happening, even with your initial testers. And it's a great way to understand where you might need to improve the agent and fix the trajectory and tool usage of it. If you do choose the Agents SDK, this comes built in and it ships it by default to the OpenAI traces in your developer dashboard, but you can also connect other third-party providers. And having this data is important because it sets you the foundation of adding evals. Evals are ultimately how we decide whether our agent is working in the first place. Since agents are non-deterministic, having evals is the equivalent of having tests in place for your code base. We run our agent and see what the trajectory of it is, meaning what tools did it call, how did it solve the output, and then we grade the performance using a grader. You can think about it similar to how you grade school assignments. All of them might have different strategies of grading. Think about like a math homework. The teacher might not care about what you did during the actual computations or whether you made mistakes, as long as you get to the final correct answer. Meanwhile, for a driver's test, it doesn't just matter that you got there in the end, it actually matters whether you made mistakes along the way. And sometimes this output and graders are also more subjective, using things like LLM as a judge, the same way that a teacher might judge 2 different art paintings. And these evals should be specific to your use case and your agent. So we're not talking about the evals that are being published when a new model comes out, but these should be really specific to your use case so that they can function as almost a canary in the coal mine to understand if a new model or a new prompt that you have actually improves the performance or degrades it. The last thing when you're getting ready to ship your agent is to have guardrails. In the end, an agent is still non-deterministic, and there's a lot of risks that you might have to deal with. Maybe you want the agent to only handle certain topics, or you're worried about the agent violating your style guidelines or saying something offensive to your customers. There's a wide reason why you actually want to run guardrails. And these can run either on the input. For example, if you're worried about the agent being manipulated to use tools in the wrong way, maybe you want to run some input guardrails and even block execution on them. Or maybe you're more worried just about the agent offending the user, and in that case, you might want to run an output guardrail. These guardrails can also vary widely from being very deterministic and pattern matching, using like regular expressions, to using LLMs again as a judge to determine things more subjectively. For the most common guardrails, we actually have a package called OpenAI guardrails that's available in TypeScript and Python that you can use to get started, and it's available even outside of the Agents SDK. All right, let me fix my microphone that keeps slipping off. There we go. So once you have your agents set up and in production, we actually need to scale. One of the first things that normally comes up is I want the agent to just do more. And while you could just add more tools and tweak your prompt, you're quickly going to run into situations where you're going to confuse the agent because you have conflicting information, or you're just overall reducing the reliability because there's too many options. And an alternative for that is to actually move to a multi-agent architecture where we group things more use case specific and have multiple agents with different prompts and different tools. And then these can interact with each other. The most straightforward thing is to use a predefined path. So, for example, you have a planner agent that creates a plan and then outputs it, and then we feed that output into an implementer agent. But there's also there's two additional options. The first one is handoffs. So handoffs are handing off the entire context of an agent or of a conversation to another agent. And this is done by having the first agent call a tool that decides that it should actually perform that handoff, and then you can decide if you want to push the full context or only part. And this is heavily driven by use cases like customer service, where you have specialized agents that have a certain subset of tools, but then you ultimately care about the full context of the conversation to serve the customer best. The alternative is delegation, and that's more where you have an agent potentially orchestrate across multiple different sub-agents that all fulfill small tasks that feed into the larger one. And in this case, basically you have the first agent call the other agent as a tool instead. On top of building more agents that solve more tasks, there's also more like harder tasks that agents are beginning to solve, and with that, longer and longer running tasks. So that can be tasks that run for minutes or hours, or we've even seen things like GPT 5.1 Codex Max that we recently released work on a single task for over 24 hours. And with that, there's a whole new set of challenges. One of the most important ones is durability. Like if you have an agent call a bunch of different tools, how do you deal with like flakiness of the tools, or even the flakiness of the harness? What happens if the whole harness goes down midway through the work? How do you recover? How do you roll back? For example, if you have an agent that plans a vacation and already booked the flights, but the hotel booking tools are flaky, how do you actually recover from that? And similarly, the longer a task takes, the less likely it is that the client, is going to stick around. So how do you make sure that if they're refreshing the URL, you're actually giving them the context back? So using things like resumable server-side events is incredibly important there. With some of the models, we're even seeing inference taking longer. For example, the GPT 5.2 Pro can take quite a while to respond, and so you're risking things like connection timeouts even on your server. So for that reason, we build into the responses API both resumable streaming, but also webhooks so that you can manage that accordingly. And if any of you use Temporal, we also have an integration with Temporal in the Python Agents SDK, so you can connect those things directly and have Temporal handle some of the things like your agent harness going away. The other side of this is if the agent works longer, it deals with more context, and the context keeps growing. For that reason, you want to manage how you're dealing with that context, especially when it comes to tools. Maybe not have a tool that reads every time the entire file, but instead progressively reads parts of the files. and navigates that way, or even fully drop tool calls later on to reset the context. The other aspect of this is as the model context grows, you might actually see the model become more antsy and feel like it's running out of time. So don't try to drive the model's context window all the way until the end, just because you have things like caching. For that reason, we actually added native compaction. So you can either do your own summary, or you can use the Responses API compaction mode with the latest models that have actually been trained on that type of compaction. So we'll handle the compaction for you, and the model knows already how to deal with those summaries. So it improves further the performance. The last part that often comes up very early on for people is, how do you actually deal with fine-tuning? Like, should you fine-tune a model for your use case? And when should you start fine-tuning it? And the reality is you should not immediately dive into that. It's not worth the effort. Instead, hopefully at this point, you have observability set up so that you understand what use cases your customers are trying to solve. You packaged up your own evals set that is actually measuring how well your agents are performing against it, and hopefully it's not at 100%, because ideally you should have room to improve. And you iterated on your prompts and tools to get to really what you think is like the maximum you can get out of the frontier models. And then fine-tuning is a good option, and one mode of fine-tuning that is especially good is agentic reinforcement fine-tuning, or agent RFT. With agent RFT, we're not fine-tuning based on input and output examples like you would do with supervised fine-tuning, and instead we're actually looking at a full agent trajectory, meaning all the tool calls and all of the reasoning traces, and then we grade based on that, either using your existing evals graders or other graders, and you can grade on things from the overall solution to the allocated tool call budget, for example. And with that, the model will then learn how do you actually solve the problem. It will try different things, get graded on it, and slowly learn what the most optimal way is to tackle certain tasks. So it's great for those agentic use cases, because you also don't really need a lot of samples. You can start with samples in the tens of hundreds rather than needing a large data set. And as a result, the model actually learns how to solve problems faster, leading to lower latency and hopefully higher performance as well. All right, I covered a lot. And as I mentioned, there's new models all the time, new frameworks. How do you keep up with all of this, especially if you're not notoriously online? First, focus on your use case. You do want to make sure that ultimately you're solving the problems of your users, not constantly try to adopt the latest framework. You should also measure your impact. Ultimately, your evals, your in-house evals should be telling you where you still have gaps and how you solve them. And if your eval, as I mentioned, is at 100%, you're doing it wrong. Make sure that you're leaving gaps so that you can understand how you can further improve. And then use experimentation. Use like an A/B testing framework, or even a user feedback mechanism to see if an agent that you're newly rolling out is actually solving the problem. Maybe have 2 agents in production at the same time and see which one is actually performing better. Lastly, I want to talk about one more thing because we have a few minutes left before we wrap up, and that's a type of agent that we talk less about, and that's voice agents. I'm personally very fond of voice agents. I worked at Twilio before, a telecommunications company. And voice agents are great. If you've ever been like on one of those like annoying phone trees that you feel like you have to navigate for 3 hours, voice agents are really here to solve those problems. But they can also go so much further. They actually make AI more accessible to users, and voice can contain a lot of contextual information that goes much beyond what text can do, both because you can convey information faster, but you can also have additional information in things like the tonal aspects of your voice. The only challenge is that it's extremely latency sensitive. You want to aim at like almost a 500 milliseconds end-to-end latency. And when we talk about voice agents, there's two types of architectures that are most common. The first one is a chained architecture. So this is where we take an agent and we wrap it into a chain where we transcribe the audio and then run our text-based agent and then take the output and turn it back into audio that we can play to the user. The alternative to that is a speech-to-speech voice agent. In this case, the model is actually trained on dealing with audio directly rather than having to convert it. That means it can skip all the additional transformation steps and instead consume every part of audio, including like sounds, for example. And this allows us for a much more fluid conversation style. By skipping the additional transformations, we have more time to do things like tool calling. We can even do things like asynchronous tool calling, where we can continue the conversation without having to wait for a tool call. And then later on, the model can take the tool call response into consideration. And as I mentioned, we're getting that full vocal context understanding. One of the common complaints about voice agents, though, that we see is that speech-to-speech models are normally not the most state-of-the-art models and are lacking some capabilities, especially with harder tasks. And this is where we can use that same delegation concept that we used in our text-based agents and actually have a voice model, a speech-to-speech model interact with the user directly, and then use delegation to send tasks to more capable text-based models and continue the conversation. And I figured we haven't threatened the demo gods here today, so we're gonna see if this is gonna work. I wanted to give you a quick example here. So I have on the left side here a real-time agent. So a real-time agent is using that speech-to-speech model. It's very basic, just literally instructions of you're a greeter. But it has two tools. It has a coding agent tool, and it has a hosted MCP tool. We're going to care about the coding agent tool here, where all we're doing is we're actually delegating to a codex agent that is running on our backend. And you can see the definition here. This is running on our server. But it's using the Codex SDK to just start a new task with whatever the voice agents send as a task, and then runs that on our system, in this case, on my developer's website project here. So we're going to go over here. On the right side, I have the dev server of the developer's website running, just so we can see if there's any updates. And then on the left side, this is where we have our coding agent. So let me connect to that. And this is going to be weird because the agents really do not like the feedback of the speaker. So we're going to see how it works. I'm going to mute myself in between. So let's see if this works. Let's wait for it to be connected. All right. Hey there.
Hey there. Great to see you. How are your day going so far?
It's great. I'm at a conference in Warsaw. Can you grade the audience really enthusiastically in English, please?
Absolutely. Let me give it a shot. Hello, Warsaw Conference. It's fantastic to be here with all of you. You are an amazing audience, and we're about to have an incredible time together.
You don't have to bother them that much.
Let's make this event unforgettable.
Can you actually ask the coding agent to go and change the subtitle on the developer's website landing page into Polish? So you can see it started a coding agent here, but we can continue to talk. Hey, by the way, can you count to like 5?
Sure thing. Here we go. 1, 2, 3, 4, 5.
Also, how many fingers am I showing?
I see 5 fingers clearly showing up. Looks like you've got your whole hand raised.
All right, and you can see here, if we ask, by the way, how's that developer's website going?
The change to the developer's website subtitle has been made successfully. It's now in Polish. So the site should reflect that updated
Can I get
text.
like a thumbs up, thumbs down? Is the translation
want me
fine?
To double check anything else?
Yeah,
Just let me know.
I get some thumbs up. Cool. Awesome. So that demo worked. Thanks, demo gods. And thank you for that applause. Awesome. All right, so let's wrap things up here. I know I'm almost like the last thing to the party. A couple of things for you to take away. The first one, if we're talking about an agent, the best way to think about it is it's the thing that solves tasks on behalf of a user, meaning it has to have tools to actually solve the problem, and it typically deals with like a model instructions, and it has some level of harness. Start simple, don't overdo it, focus on a single task and make sure it works well and that it's successful, and then iterate on that. One way you can do that is by measuring and observing what the actual model is doing. And then the other thing that I want you to take away is I want to see less agents that are just chatbots. Like, include them into flows the same way that in the places where they're already solving the problems. And then when you're getting there and your agent is actually solving problems, then go and optimize and improve it and add additional functionality. And lastly, if you're designing an agent, think about voice. It's a great interface to make things accessible. And with that, I'm going to leave this on so you can take a picture if you want to have the slides. This is the last time you can get the slides. And with that, thank you so much for having me.